volume of a sphere has the formula 4/3 pi r cube, and the surface area of a sphere has the formula 4 pi r square. The diagram shows a composite shape where a cylinder has been joined to a hemisphere. The diameter of the cylinder is 9 centimeter and the height is 16 centimeters. The volume of the sphere is equal to the volume of the cylinder. So we have to show that the radius of the hemisphere is 7.86 centimeter, correct to 2 decimal places. So what we'll start with is using the volume of the sphere is the volume of the cylinder, which is pi r square h. Pi times 9/2. Since 9 is the diameter, so the radius is going to be half of it, times 16, which is pi times 81/4. That's pi times 81 times 4. And that is going to equal 324 pi. I'm going to keep it in terms of pi right now. Then volume of sphere is 4/3 pi r cube. But since we're trying to find the volume of a hemisphere, volume of hemisphere is going to be half the volume of the sphere. So that's going to be 2/3 pi r cube. So we're going to put 324 pi equal to 2/3 pi r cube. 324 pi times 3/2 pi is equal to r cube. Pi gets cancelled out, 2 becomes 1, and that becomes 162. So 162 times 3 is 486. I'm going to take the cube root on both sides to get rid of the cube on r. So 486 cube root is equal to 7.86 centimeters, correct to 2 decimal places. Then it says calculate the total surface area of the solid. So to calculate the total surface area, first look at the surfaces that we have. Let's start with the sphere first. Sphere has the total surface area of 4 pi r square. Hemisphere will include this and this. So let's start with finding the area of this part first. So I'm going to color code this. This is going to be half of 4 pi r square. So 2 pi, and r is 7.86, which we just found. So 7.86 whole square. This is going to equal to 388.17 centimeters square. Now I'm going to find the area of this part over here. So that's going to be the difference of the circle bottom on the cylinder and the top face of the hemisphere. So I'm going to call this area, and that's going to be pi times 7.86 square minus pi times 4.5 square. 4.5 is basically the radius of this circle. 9 divided by 2, 4.5. So this will give us 130.46 centimeters square. Now next, I'm going to find the area of the cylinder. So for the cylinder, your surface area is pi r square plus 2 pi r h. Normally, you must have seen that the surface of cylinder is 2 pi r square plus 2 pi r h. But in this question, since only one of the faces is exposed of the cylinder, which is the top circle face, so that means the surface area of this cylinder would be this circle, and then the curved surface area. So that's 2 pi r h. So we do pi times 4.5 square plus 2 pi times 4.5 times 16. So all of this equals to 516.01 centimeters square. Now we go to the total surface area. Total surface area. That equals to the sum of 516.01 plus 388.17 plus 130.46. And that's going to equal 1034.6 centimeters square. That is your total surface area of this composite 3D shape. A different solid is in the shape of a cuboid. The cuboid measures 8 by 4 by 6 centimeters. These measurements are given to the nearest centimeter. We have to calculate the lower bound of this cuboid. We have to calculate the lower bound of the volume of this cuboid. So it says that the measurements are correct to the nearest centimeter. So let's find the degree of accuracy first. To find the degree of accuracy, we divide whatever the measurements are like nearest to by 2. So since it's nearest to centimeter, so 1 divided by 2 is going to be 0.5. Now lower bound of the measurements is going to be 8 minus 0.5, then 4 minus 0.5, and lastly 6 minus 0.5. So one lower bound is 7.5 centimeters, the other is 3.5 centimeters, and last one is 5.5 centimeters. So since we have the lower bound of all of the lengths of the cuboid, we can easily find the lower bound of the volume now. It is going to be the product of 7.5, 3.5, and 5.5. And all of this is going to equal to 144.38 centimeter cube. That is your lower bound of the volume of this cuboid.